All right, this is my Calculus 1 related rates problem. This is lab number 2, and this is a sliding ladder. We've done this many, many times. And here I have a ladder sliding down the wall. It's a 13-foot ladder, and it's leaned against a house. When the base starts to slide away, so the base is going this way, it's sliding away, as you can see this arrow here. By the time that the base is 12 feet from the house, so we're going to call the base X. So when the base is 12 feet from the house, so we'll just label everything as they're talking, the base is moving away at a rate of 5 feet per second. So I look at the feet per second and I said, oh, they just gave us dx dt. And since it's moving away, that's positive. So that's going to be 5 feet per second. So that's what I have so far. Now they want to know how fast is the top of the ladder sliding down the wall at the moment. So they want us to find basically dy dt. And so here's y. And the ladder, we're going to have be s. So we have x, y, and s. So the first thing we're going to do is try to figure out at the moment that the ladder is 12 feet from the base, and we know the ladder is 13, what is y? Because we have no idea what y is. So what first thing we're going to do is try to figure that out. So I'm going to do x squared plus y squared equals s squared at that moment. And I know it's 12 squared plus y squared equals 13 squared. Now, some of you might notice it right off the bat that this is a Pythagorean triple. So I know right off the bat at that moment, this is 144 plus y squared equals 169. Subtract 144, take the square root, you should get 5. Because that's 25 and the square root of 25 is 5. So at that moment, I know this is 5 feet. So I'm just going to label it. And we're looking for dy dt. Okay, so the relationship is the Pythagorean theorem. We've done this quite a few times. And a lot of times when people are like, okay, what do I do now? I just found at the moment that the base is 12 feet away, that the ladder is down to 5 feet on the wall, but I still have to do the relationship of my rates. Okay, so let's do that. I'm going to use a different color here. So I'm going to use this main one right here, and we are going to do our derivative. So I'm going to do 2x dx plus 2y dy equals 2s ds. Okay, and I'm going to go through and divide through by time because that's what most everything is based on. And I can see I can divide through by 2's and get that out of there. So I'm going to end up with this formula. X, whoops, be nice if I could write, x dx dt plus y dy dt equals s ds dt. Now, there are some videos, if you watch them and see other teachers, right off the bat, they would have put a 13 right in here for s because s isn't moving. But I'd rather have you do this like this and say, okay, if I'm looking at the rates of change, my x is moving because it's sliding out. The dy dt is changing. In fact, it's going in a negative direction because it's sliding down the wall. The ds dt, oh, wait a minute, my ladder's 13 feet, but it's not changing at all. It's just sliding down the wall. So my ds dt is really 0. So by you doing this, you can actually come up with x dx dt equals y equals a negative y. I just moved it over on the other side, equals a negative y dy dt. So I just kind of put it like this. Now we're going to solve for dy dt. You could actually divide both sides by negative y, but it doesn't matter once we put all our numbers in there. So we have dx dt, and I'm not going to put units in right now, is going to be 5 feet per second, and it's positive. My x at that time is 12, so I have 12 times 5. Now, this is in feet, the 12 is, and this is feet per second. Then over here, y is going to be a negative 5 feet, and we're solving for dy dt. So when I divide both sides by negative 5, I get a negative dy dt equals negative 12, and it's going to be feet per second that it's sliding down the wall. So that's good to know. So we just answered A. Now I might have to erase some of this because there's a B and a C, and obviously I cannot spare any space here, so I might have to erase some of this, okay? In fact, you know what? I might add a page. That's a good idea. So let's do the B part to this. Now, the B part, they ask us, at what rate is the area of the triangle formed by the ladder wall and the ground changing at the time? I'm like, oh, okay, the area of a triangle is 1/2 base times height. But because how we have our picture, we've called this X, this Y, and this S. So I'm just going to change my area is going to be basically 1/2 X times Y. And then when I want to find how fast the area is changing, I'm really looking for dA dt. So that's what we're looking for, the change in the area, which is a little bit different, but it's cool. So they just want to know what the change in the area is. So now what I'm going to do basically is do the derivative of this. So I do dA equals 1/2. And when I take the derivative of xy, if this is my f and this is my g, if you remember, it's going to be x dy plus y dx. Okay? And I'm going to divide through by dt. If you kind of don't remember how I did this, if you did f here is x, f prime would be dx, g is y, g prime is dy, and if it's a product rule, it's going to be f prime g, y dx plus x dy, which I just wrote it the other way, but it's there, okay? Now, we're solving for dA dt, so now I'm just going to plug in all the stuff, and we know all of this stuff. So let's kind of go through this. Ready? So dA dt is going to equal 1/2. And then I'm going to plug everything we know. We know x is 12 feet. dy dt we just found was negative 12 feet per second. Plus y at that time was 5 feet. And dx dt was 5 feet per second. And then when I put this all in my calculator, I get a half of 12 times a negative 12 times plus 5 times 5. dA dt is negative 59.5, and it's feet squared per second. Now, the one thing that I want you to see is how the units work. So this is x is 12 feet. dy dt is negative 12 feet per second plus 5 feet times 5 feet per second. So look what you have. You have feet squared per second, feet squared per second. I'm adding it. That's where the units come. So there is a change in the area. Now, that should make sense to you if, I'll go back to my original picture, if this is sliding down, and I'm going to do one of those pictures in class, the area of that triangle that it's formed with the wall in the ground is getting smaller and smaller. That's why your area is decreasing. All right. The last part of this problem is our famous, how is the angle changing? So here's my picture again, the ladder, the wall, and the ground. I'm looking for how that angle is changing as the ladder's sliding down and going out this way. So here's my beautiful picture. Okay, so we're looking for that angle. Now, again, look at what they gave you. They gave you that this ladder is 13. So I personally would pick, you can pick from any of the 6 trig functions, but the major three major ones like sine, cosine, and tangent, I definitely would pick something that has the hypotenuse in it. So you're talking sine theta or cosine theta. But then I go, well, they gave me x. They gave me x, and so I'm going to use cosine. So I'm going to do the cosine of theta is adjacent, which is x, over my hypotenuse of 13, okay? I want you to think of this as 1 over 13x, okay? Now we're going to find the rate of change of my angle. So the derivative, okay, of cosine is negative sine of the angle, d theta, and the derivative of this side is going to be, think of this as a 1, it's going to be 1 over 13 dx, and then we'll just divide through by dt's, okay? Now, after we go to do that, I'm actually going to solve for d theta dt. So I'm going to write d theta dt just so I can plug everything in is going to be, if I divide by that, it's going to be negative 1 over 13 times the sine of theta. I'm just going to put it here. Now, do you have to do that? Absolutely not. You could actually put the numbers in extend the page and do this, okay? So first thing is, everybody's like, okay, I get what you did so far, but now I've got to start plugging stuff in. So I have -1 over 13 times, now I have to do the sine of theta. Well, the sine of theta at the moment, okay, that this was 12, or was that 5? No, it was 12, and then this was 12 feet. This was 5 feet. Remember we did our Pythagorean triple? Well, at the moment, what is sine at that moment? What is the sine of the angle? Okay. Well, sine of theta is opposite over hypotenuse. Okay. So in this whole spot, because I don't care if I have the angle, but I know the sine of it is 5 over 13, I'm going to plug in 5 over 13 right in that spot. So I'm going to plug 5 over 13 right in that spot. And I know dx dt because we already found that out before, and dx dt was 5 feet per second. So we have everything we need. The cool thing about this going on right here is I can say thanks for playing. So you really have -1/5 times 5 over 1. They cancel out, so you get -1 radian per second. So they made this out nice by having it be a -1. But that would be the answer to that. So I think I've covered everything that is in that problem. Is we talked about how the angle's changing, and before that we did how is the up above here we did how the area is changing, and then here we talked about how the dy dt is changing. So I hope that helped you, and see you in class.